Good morning, good afternoon, and good evening, everybody, depending on where you're joining us from. And welcome to Automated Testing Beyond Unit Testing for Mainframe, the third webcast in our modern mainframe DevOps series. For those of you who do not know me, my name is Len Thompson. I'm Broadcom's Mainframe Division Community Manager. And again, I'd like to welcome you to today's session. Before we hand you off to Sujay, just want to let you know that we are recording today's session, which is why you're currently all muted. If you have any questions along the way, please use the questions box along the right side of your screen, and I'll go ahead and read those towards the end, and hopefully we'll answer as many as we can during our time together. If we have time at the end, I will also let you know how to have your line unmuted if you prefer to ask your questions that way. The recording of today's session will be posted out in the Mainframe DevOps community later today or first thing tomorrow. So if you have colleagues you'd like to share it with, you can point them there. And the last thing for me is we're always trying to ensure that these sessions are valuable. With that in mind, I put together a short survey that will appear at the end of the webcast. I'd really appreciate you taking a few minutes to give us some feedback so we can make sure that the next session in the series is even better. And with that, I'm going to hand you off to Sujay, so take it away, sir.
Thank you, Len. So Sujay Solomon here. I'm a product manager who works on the mainframe DevOps as well as open mainframe section of Broadcom. And our topic today, as Len mentioned, automated testing beyond unit testing for mainframe. However, I am actually going to also cover unit testing. So we'll start off with kind of just the basics of testing applications. Then we'll talk about automated testing. And then the different facets of automated testing, or just testing in general, is unit testing, integration testing, system testing, acceptance testing, sort of at a general level. And then we'll key in on how those relate to mainframe in particular and what the possibilities are. And then we'll sort of wrap up and talk about what's happening both in the distributed as well as the mainframe industry when it comes to testing and the trends that we're seeing there. Okay, so, software testing at a very basic level, what is that? So software testing is defined as, just being able to check whether after some changes are made to a program, the actual results from testing that program match the expected results, and by which you're essentially making sure that the software system that you've created is defect-free. So that is the intent of software testing. Now, software testing doesn't always mean that it's automated, right? There's lots of different ways of testing, and usually it's split between a subset which is tested manually versus some that's tested automatically. So, and that brings us to automated testing. So, in the world of software testing, test automation is essentially another piece of software. So test automation is also software, which is different from the actual program, the software program that you're testing, which does a few things. It controls the execution of the program that you're intending to test, and it performs comparisons of the actual outcome from running those tests with what you expect the outcome to be. Now, test automation is able to automate many of these tests, right? But it's not necessarily that you have to only automate certain parts of testing. It comes down to really the value that you get out of testing. So priorities have to be placed on what is a good candidate for automated testing. So if something is repeated all the time, and the value you get out of testing it is of a high number, then that's a great candidate for automated testing. In another case is if you're really risk averse and the chance of an error in a program having extreme consequences for your business, those are also good candidates for building automated tests for. Now, breaking down automated or software testing, this is a common pyramid that's presented as part of the different facets of automated testing and testing. So all the way at the bottom here, we have unit testing, which we'll talk about, integration testing, system testing, acceptance testing, and there's still a little bit of creative manual testing that goes on right here at the top. Now, each one of these kind of parts of the pyramid of testing can be broken down into further different types of testing. In this webinar, we're not going to get into that level of detail. We're going to stay at this greater level here, but by unit integration system and acceptance. But as I mentioned before, what we'll do is we'll hit each level of testing. We'll look at it from just, a standard testing practice perspective, what those tests mean, and then we'll kind of dive into what it means in particular for the mainframe platform and common applications that run on the platform, and what tools are available today to actually perform that testing. So we did a survey, and we found out with some of our own mainframe customers that when it comes to unit testing, there's a little bit of it that's automated. A lot of it is manual. So for example, the way developers test today is, they make a change to maybe one particular module, and they have some JCL that's able to execute just that specific module. And they essentially test it manually by running it as maybe a batch job, and they make sure that the results are good. That's mostly how testing is done. And in a lot of cases, even that's not done. Especially if it's a peripheral module that they didn't actually make changes to, but maybe one that's being called. A lot of times that just goes untested. Integration testing, and we haven't even gotten into what that is yet. But barely anything is automated there. There's a little bit that's done manually, but for the most part, on the mainframe side, not a whole lot of integration testing is done. System testing. A decent bit of it is automated. A lot of it is actually panel-driven automation that folks have built out over many decades, and then a lot of it is done manually. So there's very explicit instructions that are well documented, which the QA group essentially takes that set of manual steps and they replicate it every time before a new release or such. And there's a little bit that does go untested here, but you can see from these results here that there's a fair amount of testing that's done that potentially could be automated, which is why we're starting to share some of this information here. Okay, so let's actually start walking through the pyramid bottom up. So what is unit testing? Unit testing is testing the smallest testable portion of any software. So generally, when you're doing unit testing, you only have one or maybe a couple of inputs, and most likely just one output that's expected out of that call. And it's usually created by developers, or in some cases, it's even generated without a developer manually doing anything. The frequency at which these unit tests are updated or created is every time a code change is made, you're going to either create new unit tests or you're going to update them. And the target, of course, smallest testable unit, depending on the language, this might be different. So, if you're working with C, it might be a function. If you're in Java, it might be a method. It could just be a program in COBOL, or maybe just a paragraph. But another convention with unit testing is that a lot of external calls are mocked in unit tests. So for example, if I was making a proprietary database call, it's very likely that call into an external database is mocked in this unit test, so that you're able to invoke that test and run it without having a dependency on a whole lot of external things running. So that's just common convention that you see with unit tests. From a platform perspective, typically these unit tests just run on developers' workstations, because the idea is that as you're developing code and maybe performing a build, you're constantly running these unit tests to make sure that whatever code changes you're making isn't damaging anything that was the logic that was created by somebody else perhaps in the past that's in the module that you're working on. So that's just common convention. Okay, so tying this to mainframe applications, and now in this example, very quickly, just to get you used to, you're going to be seeing this image over and over again for different parts of our testing here. So we've got two L bars here. It's just a very common CICS DB2 model. On LPAR1, there's 2 CICS regions. In the first region, there's 2 programs here, program 1 and 4. In the second one, there's program 2. In CICS3, there's program 3. This is in the second LPAR. There's a transaction here that invokes this program 1, which invokes program 2 in CICS region 2, which invokes program 3 in CICS region 3, and then ultimately that goes in and makes a DB2 call. Maybe it's a lookup, maybe it's a write, whatever it might be. So that's a pretty standard setup there. Another transaction here, simpler one, it just goes to program 4 in CICS region 1, and that performs the DB2 lookup directly. So I'm showing this because, a unit test, the scope of a unit test most likely is just going to be one program that's located in this CICS region, right? In CICS 1 here. So there's unit test for program 1. There's a separate unit test for program 2. And so on and so forth. For each of those programs, you're going to likely have a separate unit test. Now, let's actually break out of this, and we actually, we built out some code to run this application. So what you're seeing here is actually an app that we built. It's a CICS DB2 application called Marbles. Keeps track of an inventory of marbles with quantity and colors involved with each marble that's in that inventory. Now I'm going to open up the code for that, and this is open source. We have it on public GitHub here. So when we look here, you're going to see that within this procedure division, there's multiple paragraphs here. So let's go to get trans input. So if we go to get trans input, that's this paragraph here, and you can see that all it's doing is it's receiving input from the user by performing an exec CICS receive. So that's a single paragraph, and single paragraphs are candidates for unit tests as well. So you could either do it at the program level, or more preferably with COBOL, you could even do it at the paragraph level. So where do we stand today with unit testing and mainframe? For the most part, there's not many unit tests that are automated. Not many applications actually keep track of code coverage with their automated unit tests. Most of the unit testing that's done today is done through manual custom jobs, JCL, to maybe test particular modules. So that gives the developers some comfort in the change that they've made. The goal here, across the software industry, is you want to achieve 80% or more of code coverage of all paragraphs in each program. Obviously, the 80% number is just sort of a standard number that's aimed for in the software industry, but borrowing that into the mainframe industry as well makes total sense. Now, on the tools side, there's some free and open testing frameworks. So let's click through this one. I think I have it open here. So this is this is just an open source COBOL unit testing framework. It's anybody can go in and use this. Actually, no affiliation with Broadcom. I just, as a user, I came across this and found it pretty useful. The goal here is to help folks with writing isolated unit tests for individual paragraphs without a connection to ZOS. So that is key there. Remember I said unit tests ideally run on developers' workstations without them having to need any sort of external platform dependency. It should just be able to run on their own workstations. So this is sort of helping with doing that, where they have some level of mocking that's available for IO that might happen that's platform reliant, or these sort of exec CICS statements that require CICS to be running. It's able to mock some of that, which allows you to run these unit tests without having to actually run them on ZOS. Now, a lot of folks might look at that and say, hey, what's the value in running these unit tests if you're actually mocking a lot of these calls out? The value is that, for the most part, if the logic is encompassed in the COBOL code itself, then your unit tests that are automated and running all the time are able to catch small mistakes that developers might make as part of them changing the code very quickly. So it accelerates their development. They don't have to go on platform each time to test things. So that's the free one that I've come across. Now, in addition to that, there's quite a few unit testing frameworks that are commercially available. So IBM has something called ZUnit. They've also mentioned a newer one called Z Open Unit Test. CompuWare has Topaz Total Test. Now, again, all of these require you to run it on ZOS. Now, that might be okay for the most part, but as a developer, when I worked on Java and other languages, I was able to run my unit tests. Maybe not my system integration and performance tests. They don't necessarily make sense to run on my machine, but I really appreciated the fact that I was able to run my own Java unit tests locally on my machine. So again, just maybe take a leaf out of that for mainframes as well. So that was unit testing. I know we said we're going to cover things beyond unit testing, but that was sort of a basic introduction to unit testing and mainframes. Now, moving on to integration testing. What is integration testing? So integration testing aims to take components that maybe were previously unit tested that work together as one integrated component, test that, and expose whatever defects might be present in those integrated components, because at this point, you're testing these interfaces and the particular interactions between these components that were previously unit tested. So unit tests work at the smallest unit level, and you can probably just give it a small piece of input and you expect one output from that. Now, with integration testing, you're putting a lot of those units and those little components together into one component, one integrated component that actually does something of value. And during that, you're actually testing all the interfaces and the integration points between those disparate components. Now, who creates these integrated tests? So generally, both QA and development are generally involved in this. They sort of come up with what is a good candidate for integration testing together. As far as who actually automates integration testing, that really depends on how your organization is sort of structured. What we're seeing is more of this testing is happening within the development teams, where folks don't really have specialized titles like you're a developer, I am a QA person. It's more of you're a software engineer and you do everything from working on product code to being able to write automated tests, whether it's unit testing, integration testing, whatever, performance testing, all of it. Now, that doesn't mean that folks may not have their preference or maybe their specialty in some of it, but what we're starting to see is there's a lot of cross-pollination there where developers, software engineers tend to do all of it with maybe a little bit of a preference to maybe testing versus writing new code. Now, how often is integration testing created or updated? Usually this happens when developers or dev teams merge their code into a common repository. Now on the mainframe side, this might involve maybe promoting code into a certain stage where it needs approval. So before that approval is given, these integration tests are written, ran, and the results are provided for whoever might be ready to approve that change. Target, of course, is integrated components that actually work together to give you a meaningful input and output. Conventionally, test data when it's needed for integration testing is just fabricated rather than using real data. And platform requirements for integration testing. Now, this is where we stop mocking those calls. So we don't mock out the database call. We don't mock out the IO calls. But what is common here is that integration testing usually runs on virtualized environments, which is a step above just running the test on a workstation on somebody's developer laptop. But again, it's virtualized, so it should be more accessible than maybe real hardware. Now, just quickly, just to point out the importance of integration tests here. So in this image, we're showing what would happen if only unit tests were created and written and ran, and integration tests were never performed. This is what could happen, where those two doors were tested to function, the handles were tested to function individually, but nobody actually tested them working together. So this is what could happen. Now again, coming back to our common CICS DB2 model here that we looked at for unit testing, let's look at it again and kind of look at what integration testing means in a mainframe world. And in this particular CICS DB2 scenario, one particular integrated test would be this transaction 1 invoking program 1, which invokes program 2, which invokes program 3, and then finally does the DB2 lookup. That entire sequence would be one integration test. Same way, transaction 2, program 4 into DB2, that would be yet another separate integration test. A quick sample flow for what this integration test might look like. So you would start off by perhaps invoking the CICS transaction. You would check to make sure that the correct output is passed from program 1 to program 2. And then the same, again, from program 2 to program 3, we have to make sure that the correct output is passed there. Then check to ensure that the correct database lookup is actually performed by program 3. And then finally, make sure that the proper data is returned to the caller of the CICS transaction. So that's an integration test sample flow for this particular sequence that we saw here with transaction 1. Obviously, for transaction 2, it would be a lot simpler, that same sequence. Now, from an implementation option perspective, there's really not much done today in the industry as far as integration tests go with mainframe. Ideally, again, you want 80% plus coverage of all transactions that you might have. Obviously, it would be good to prioritize which transactions are most used or which transactions are most business critical and focus on automating those first. And then in terms of tooling that's available to perform this testing, from a free or open source perspective, you might have heard of Zoe as a command line interface, the open source project. The combination of Zoe CLI plus some asynchronous testing frameworks like mochaJS, Jest, or Robot. So some of these are JavaScript based, Robot is Python based. These help with writing integrated tests without a tight dependency on the platform. It's able to actually asynchronously call these operations on the mainframe as needed, but most of the assertion logic, the comparisons, and all of that happen off platform in JavaScript or Python logic. Now, some pay for options here. There's 3270 screen scraping automation that's provided by Rational Testing Workbench, which is from IBM. Within Broadcom, we have something called the BlazeMeter RTE plugin, which helps again with panel-driven automation and even doing performance testing for that. Micro Focus has something called UFT. Now, these are all 3270 screen scraping oriented automation. So for example, you might have CICS panels that are 3270 based. You might use these automation tools to go in and drive those particular transactions through a panel. Now, the previous one I talked about here, being able to invoke Zoe CLI from these testing frameworks, that does not rely on panel-driven automation. In fact, that's driving some REST APIs on the mainframe to actually allow you to invoke these transactions and test them. And then the last one here is, I mentioned another convention with integration tests is generally they run on virtualized environments, and there's a few options for that today. So IBM has a product called ZDNT, which runs essentially ZOS on x86 hardware. That's an option when it comes to virtualizing and running some of these tests off platform. Within Broadcom, we have something called CA service virtualization. And again, that's able to mock a lot of the CICS and DB2 pieces. It does require a small component to run on ZOS, but if MIPS consumption is a concern when it comes to running these tests, virtualizing your access to ZOS using some of these products that are out there is a good option, because we do understand that running a lot of automated tests on Z hardware today can become expensive. In addition to this, I'll point out one more thing where IBM has now come out with container-based pricing, which allows you to take sort of developer and testing workload and have different pricing for that. That's again another consideration when if you're concerned about the MIPS consumption that's involved in automated testing. There's plenty of options out there today to address that. Now, I've been talking about this integration test through mochaJS, where we use Zoe CLI. Let's actually go and look at that here. So again, this is on public GitHub. So if you go to github.com/Broadcom and then you look for things named with Brightside, there's a lot of samples out here. So you can see here, we're describing this marbles test here, setting a timeout. In the comments section, we're describing the test. So we're saying, the first thing to do within this CICS DB2 app, create a marble with the cost of 1, do some verification that worked. Try to actually create that marble again. And in this case, that should fail because we've already created that in the first one. So there's some negative testing done here as well. And if you look at the implementation here, we're saying if should create a single marble with a cost of 1. So that's our first test that's running here. As part of that, we're calling a function here called create marble. And then once the marble is created and we give it a quantity of 1, we then go and get the marble quantity to make sure that the expected value of 1 exists for that specific type of marble that was created. And let's go look at what's in create marble, that function. Here we go. So you can see here in this function called create marble, we're issuing in this case, we're using the primary command bright that could also say Zoe. We're issuing a Zoe console command. So this is actually issuing an MVS console command to do a modify on the CICS region to invoke the transaction. So likewise, we're issuing more console commands here. In this case, we're submitting some batch jobs to query the database to get the quantity of the marbles back. So again, just a whole lot of JavaScript and modern scripting ability here, which is enabled by the fact that you can call Zoe CLI from some of these popular testing frameworks here. And let's go back here to our test. So you'll see here that the assertion that's done is actually done through something that's built into Mocha. So you can see here that assert.equal is essentially doing the assertion to make sure that the message that we saw is matching what the expected result is. So those are some of the advantages of using these frameworks, is you're able to do these assertions quite easily. It also produces some reports that are quite useful. So I'm gonna switch focus here. I'm on Visual Studio Code. It's a popular IDE, but that's just noise at this point. But assume here that I've made a code change and I want to run some tests now to make sure that I didn't break anything. And this is again the same marbles application. So what I'm going to do here is that same test that we just looked at, the code. I'm on my IDE. mochaJS can be executed through npm node package manager. So I'm going to say npm test, hit enter. That's going to go ahead. This test is executing on my laptop. However, using those Zoe CLI calls, it's actually doing inventory manipulation on a ZOS system on a real LPAR that's out there. So you'll see here that it's going to run through all of those tests one by one here. So we're creating the marble. So this check mark here says that that actually succeeded. This tells you here how much time that test took. And this is, moving. I've moved between development on different platforms and different languages. And this is a very common way of writing and running tests is the logic for the test. So meaning the invocation of the test, what exactly we're testing, the assertions, the comparisons, all of those are happening using off-platform testing logic, like the JavaScript that I shared with you. The only piece that's actually executing on the mainframe is the invocation of the CICS transaction, the acquiring the data from the database. So just minimally what information you actually need from the mainframe, we make calls, asynchronous calls for that into the mainframe, get that data, and then all the testing, right? All the comparisons, all the assertions are just happening here off platform. So that entire suite of tests, right? So these 5 things, 6 things here, which also included some negative testing, all ran. And within a minute, I was able to realize that, hey, I didn't break anything in the code. So I just took a minute to run, all 6 tests passed. It even produces a nice HTML formatted report. So if I switch to my browser here, I'm on Chrome. As part of running that test, it produces this report for me. It tells me that all of the tests passed. It tells me how long each one took. And if you want to look into more details, it even tells you what the actual assertion was here. If any of these failed, it'll have a red X mark here, and it'll tell you exactly what part of the assertion failed, like what was the expected output and what the test actually ended up seeing. So again, these reports are pretty useful, especially when combined with some of these CI/CD tools like Jenkins. You might have continuous testing going on where a team of developers, right, make some changes. Maybe every night, continuous testing is going on the code that they're changing. When they come in the morning, they just go and look at this pipeline as part of the results. All the tests have run, and it's just right here for them to look at. And that report that we saw, that can also be stored off within these Jenkins environments. And executing this test from Jenkins is just as simple as the way I executed it from my own IDE on VS Code. I typed out npm test. In this case, from the Jenkins file, you're executing npm test, and that's going to run it in this test step of this pipeline. So again, very easy to create the tests. All the assertions and comparisons are happening off platform. The only time we reach into the mainframe is when we need to maybe invoke a transaction or get some data that needs to be verified. Pretty normal way of writing tests, and we're trying to really borrow from what other platforms are doing and what developers are used to there and bringing that into the mainframe side as well. So that test is out there, so you're able to actually take that, and if you want to modify it and play around with it to see how yours might work, you're free to do so. It's open sourced. Now, moving on from integration testing to system testing. Now, system testing is to evaluate the full integrated system. So remember, for integration testing, we took some units, some components, which were integrated together, and we tested them as separate integrated components. What we're doing here is we're taking the entire fully integrated system, and we're making sure that that fully integrated system actually complies with what the requirements were. Now, the requirements, some of them might be functional, some of them might be non-functional requirements, like, for example, load testing, performance testing, reliability and security testing. These are all parts of system testing. So the system testing is sort of an umbrella for both functional requirement testing as well as some of these non-functional things like load, performance, reliability, and security testing as well. So that's a pretty big topic, and I probably won't be able to touch on all of it. But again, that's one of the major parts of the pyramid of testing here. So generally, who kind of defines what needs to be in scope of system testing? That's almost always done by a dedicated QA team, which is responsible for quality and what gets out into production. When are system tests updated? System tests are generally updated when integrated components are actually working together to form a full working system. You wouldn't really start doing system testing until you have an application that's actually working and providing value. From a what is the target of this? Is you want to test a full traversal of each integrated component. Generally, this means you start from whatever the user interface is, whether it's graphical, whether it's command driven, or maybe batch driven, whatever it might be, to maybe the back end for that UI if it's a graphical one. From there, invoking APIs or any sort of an enterprise service bus type thing. From there, being able to invoke transactions as well as the going to the database is sort of a full traversal of that. Conventionally, test data even here is fabricated, but for some things, it's possible that they might take some very production-like data and mask some sensitive things out of it and use that to feed it into some of these tests. And from a platform perspective, system testing is usually done on real non-virtualized hardware. So this is really where you've got to start running this on real Z hardware. If that's where your production code runs on real Z hardware, you want to do your system testing on the same type of hardware and environment. All right, so we're going to expand out our model a little bit here. You can see here I've added a couple of things. So the rest of this remains the same for our Marbles app. But in this case, we have an end user UI. Maybe that's a mobile app. Maybe it's browser-based GUI. Typically, the backend for that is going to call into an enterprise service bus that you have hosted somewhere. And then through that enterprise service bus, you might be invoking some of these transactions that are in your CICS regions here on these LPARs. So that's pretty typical there. The scope of system testing would be this entire thing. So starting all the way from what your end users interact with, whether it's some of these apps, the mobile browser-based apps, or maybe batch apps, into this service bus, and from there through these transactions, and getting data all the way from the user through all these transactions into the database and getting some output from there as well. So that's sort of the scope of system testing. You're at this point, it's crossing multiple platforms most likely. It's possible that this app is hosted on the cloud. This enterprise service bus might be running on your internal x86 servers, and a lot of this transactional logic and databases are probably running on Z. Now, in addition to just testing that functionally, remember I mentioned that as part of system testing, there's also non-functional things that are tested. So you're likely testing response times. You're probably testing things like, hey, how much CPU, how much I/O, how much disk space, how much spool, how much memory is all being used by maybe these CICS regions, maybe the entire LPAR. So this is where things, creativity comes in. You've got to understand what is relevant for your application, where your SLA requirements lie, and prioritize the correct metrics that would help with making sure that you're going to meet your SLA. Now, just like integration tests, I'm going to go through a quick sample flow here. With this system testing, one possible flow could be you perform your UI operation, and maybe that's even automated by some browser, headless browser-driven automation. Trace that UI invocation into the ESB, into this enterprise service bus interface. From there, trace it into invoking the CICS transaction, maybe through something like MQ. Then trace that CICS transaction to actually perform the DB2 table lookup. And then make sure that the proper data is returned all the way back to the UI, which was invoked by the end user. Now, taking load and metrics also into the picture, here's a slightly different flow. where you're potentially invoking the UI operation concurrently rather than just once. You keep track of your response time, you're tracing your UI invocation into the bus, and the same scenario, but in this case, you're also tracking the response times in each case. As part of going from the ESB into CICS, tracing from CICS to DB2's table access, you want to track system metrics like CPU, I/O, memory usage, make sure that the data is returned back properly, report the response time for each concurrent UI operations response. So you want to do some trending there. You want to make sure that as the load increases, that the response time doesn't degrade too much, or even if it does, it should be within expected limits. And that's the point here of being able to do that trending here. You might also want to do that comparison across previous runs. So that's where the key is. If you made a code change and you've been running these tests every time a major set of code changes were added, you can always compare your current runs response times at each of these levels and compare it to a previous one and say, hey, you know, our response time stayed consistent, but it looks like some of these metrics, like for maybe you're just starting to use a whole lot of CPU on one LPAR as part of running these tests, or you're performing a lot more I/O than what's normal for this application. That might be expected depending on what the code change was. But it's always good to catch those and alert the teams and say, hey, your recent change that got approved and came through here, we caught this in system testing where we're incurring a lot more CPU load or I/O usage on these LPARs related to this CICS region. And that might be something that they look into, and maybe that would prevent some sort of a SLA miss down the line. Now, implementation options for this. There's really not a whole lot of system tests that are automated today. Now, the load test, performance tests generally are, like I said, panel-driven ones. But you want to, a good goal is 60% plus end user functionality really should be automated from a testing perspective. What tools that are available to do this? There's of course these free and open source ones. So again, those same asynchronous testing frameworks that I mentioned before, Mocha, Jest, Robot. There's more out there in combination with Zoe CLI will help you build some of these tests. There's also other free and open ones. Selenium and Jasmine help with UI-driven testing. JMeter helps with writing performance tests. Again, that's also free and open source under Apache. And then there's some commercial options out there. Again, these are 3270 based for mainframe. I mentioned before, IBM's Rational Testing Workbench, or Broadcom has BlazeMeter's RTE plugin, and Micro Focus has UFT. But again, these are all panel oriented, while this option that we have here is more so programmatic. So I will switch focus here and quickly run this demo here. I'm in VS Code again, and in this case, I am using a video here. So we're in VS Code. We're gonna, in this case, we're using BlazeMeter. So we used BlazeMeter's command line Taurus to execute test.yaml. What you'll see here is that's gonna invoke Taurus in this GUI, and it's concurrently invoking a lot of input into a browser page. So that browser page for Marbles actually invokes the CICS transactions under the covers. So this is invoking that, refreshing that page and providing input over and over again concurrently, even in parallel. And we're gathering a whole lot of metrics, including metrics from the mainframe. And that's not just restricted to response time. So you can see here that we're, I'll pause here. So all of the concurrent tests were executed using JMeter, BlazeMeter, and Taurus. And then that produced response times for each of those concurrent invocations. But in addition to that, with the help of Zoe CLI, what we did was we were able to actually capture CPU percentage and I/O count and all of these details from a performance management product on the mainframe called SysView. Now, we happen to use SysView. This will likely work with any performance management tool that runs on z/OS. And interfaces like this help you with actually getting more metrics into some of these load and performance testing frameworks. And that's key because they thrive on data like that to detect if something is different from a previous set of changes that were made and capture that change, alert the dev teams that, hey, there's something off here. It might be expected, but we just wanted to alert you and give you the chance to maybe review what's happening there. So that's a quick example. Again, this test that I just showed is actually also available for, we open source that as well. And so that covers our system testing topic. And I know I only kind of scratched the surface on that. There's a lot more to it. Load testing, performance testing, security testing. That's all under the umbrella of system testing. But moving on from system testing, the next step, acceptance testing, is the part where you're really evaluating the system's compliance with some business requirements, and you're assessing whether it's acceptable for delivery or not. This is usually created by stakeholders like support or maybe even your beta users, where you're giving them a chance to just use the application before it's deployed into production. This is generally done before the rollout of a major application update. And the target here, it's going to vary. It's the coverage is really usually done by the number of testers. As many people as you can recruit to testing this is great. And then there's going to be variety in the testing, so we rely on that as well. Conventionally, this is just time boxed. There's maybe we run a beta for a couple of weeks or maybe a month, and beyond that, it's really, we're relying on the number of folks and the variety that's there. Now, with the amount of automated testing that we've done, the amount of time that you have to do some of these time box tests is very, very low. And you really only have to do that before some of these major application rollouts. A lot of folks might say this actually goes against the essence of DevOps, because DevOps says if you have a lot of these automated tests, you should just be able to run all of that and be able to release into production. And yes, that is possible as you slowly gain confidence in your tests. But as on the mainframe side, since we're on the path to adopting more and more automation, we can't really race to that just yet. Now, beyond acceptance testing, there's manual testing. Again, you want this to be minimal. This is actual folks sitting there in front of a keyboard and doing these tests manually. When is this appropriate? You might have some corner cases which were just so difficult to automate. Maybe there were some extenuating circumstances. Maybe it was a high priority hot fix. In those cases, you might be in a place where you need to manually test these corner cases. The other aspect to keep some little bit of manual testing around is that occasionally testing manually kind of gets us thinking in a creative way for what other testing opportunities exist. If you're just sitting there writing code for a test, you're most likely just testing the obvious things. The act of actually going through and manually testing things will likely give you some ideas on what further could be automated. So it might be an exercise that's worth performing every now and then just to see what other things can be automated. So, in summary here, unit tests are sort of the most expansive set of tests. They aim to test generally the smallest unit of code. For mainframe, this usually means if it's COBOL, it could be programmer. More likely, each individual paragraph should be tested by these unit tests. With integration testing, it's a combination of all the unit tests which aim to actually work together as one integrated component. For each of those integrated components which have a specific input and output, you want to write a single integration test. So for mainframes, this generally means a particular transaction and the full chain of programs and maybe the database call that's involved in completing that single transaction call. System testing is being able to test the full system. So take all of your integrated components. They should be working together as one fully compliant application that provides value. At that point, you're ready to do unit testing. And this, on the mainframe side, this usually involves whatever the UI might be. If it's graphical, from there to service bus interface, from there into perhaps CICS transactions and the database lookup. And doing that for every possible user interaction. Acceptance testing is again testing the full system, but also with non-functional requirements, and usually done with a lot of stakeholders in play, like support and your beta testers and such. Manual testing is yet to be automated tests and some creative testing. Now, where's the industry going with this? Shift left testing is an approach to software testing that's really up and coming. What we've noticed is on the graph here, if you look, most defects are injected by developers as part of coding. And then this orange curve shows when those defects are actually found as part of testing. You can see here, there's a lot of defects that are found through unit functional system testing, but there's plenty that's found after it's released, which is really unfortunate because the cost of fixing a defect that's in production is 640 times what it would have cost us to fix it when it was during the development phase. So an enormously high cost when you have to fix a defect in production. So because of this, the industry is adopting shift left testing, which initially it actually reduces the number of defects that's injected by these developers because the culture itself changes. Developers take ownership of the quality rather than relying on some other siloed QA group. And what's happening is more and more of these tests are run earlier in the cycle, which means the number of defects that's found is much lower when you have shift left testing in place. So, the entire suite of testing that we talked about needs to be done earlier and earlier. And if you need to do it earlier and more often, that's where automation comes in. If you can't automate those things, then you can't scale. If everybody's spending their time testing, when are you actually building new code in, right? So that's the story here. And just with mainframes in particular, this was a survey that we conducted recently where we asked folks over the last couple of years, what has actually led to changes in the way you test your mainframe applications? And the response here is quite telling. Let's just look at the top three here. The main reason that perhaps folks are starting to look at automated testing and other ways of testing beyond what was done for many decades is that the people who've been doing this testing for decades, they're leaving the industry. So we need to be able to transfer that knowledge into a medium that can be repeated by anybody. So that's the main reason. The second one here is quite common that I see is adoption of DevOps across platforms, across applications. You can't just say, hey, I'm mainframe. We haven't really ever done this and we're not going to get on board. That doesn't fly anymore. If you want to meet SLA, if you want to be part of the enterprise platform of excellence, you've really got to start playing in this world of DevOps where automated testing is so key. And the third reason, with more and more workload that's growing, performance and quality issues are becoming even more important, right? If you miss an SLA, the impact that it has on your business is quite big. So that's probably another business reason to start focusing on more of this testing. So the takeaways here, combined with pipelines, automated testing at all these levels can really increase the confidence that you have in an automated delivery pipeline. Without this testing, an automated delivery pipeline isn't all that valuable. To gain confidence in it, you have to combine these continuous integration and delivery pipelines with a strong, robust set of automated tests. When these pipelines lower the defect rate, and actually are able to sustain it for a long period of time, that's when your release managers will start relaxing their rules on deployment and change windows. and you might actually really be able to be agile and start making more code changes, providing value to your end users quicker. So that means gradually the number of approvals that are needed may go down, and the amount of manual testing that's done will also decrease. And in effect, more value to your end users faster. So a lot of what I shared, the tests, the sample code is all available on public GitHub. You can see here most of it is under github.com/Broadcom. A lot of it is under the Brightside name. But with that, I'll conclude our webinar today, and then I'll announce here that we do have a couple that's coming up on May 21st with DevOps.com. We're doing a webinar on APIs and the role that they play in modern DevOps. So, things like ServiceNow and any sort of a homegrown dashboard GUI app that uses APIs. So really the fundamental role that APIs, operational administrative APIs play in DevOps today is our topic for May 21st, 11 o'clock. June 18th, 11 o'clock, we're continuing our set of webinars on CA Mainframe DevOps Community. So you'll be able to go to our communities page for Mainframe DevOps and register on there. And the topic for that one is mainframe automation and being able to really pull in continuous integration to fast track your application changes. So with that, I'll hand it over to Len. If there's any questions that are out there.
Thank you, Sujay. I don't see any questions coming in. And we're kind of at the top of the hour anyway. Just want to remind everybody that the replay for today's session will be posted out in the community either today or tomorrow morning. And again, please go out and register for these upcoming webcasts that we're doing. And actually looks like we might have one question. So I'm going to unmute somebody to let them ask it. Go ahead, Ed.
Hi, Len. I was just going to say, can you email out any links that were from the recording so they're easily accessible?
Oh, sure. Yeah, I can take care of that. You guys will all get an email from me later today. So if you have any questions, feel free to just respond to that one, and I'll get you anything you need. All right, I guess that's it. And with that, we'll wrap up today's session. Thank you very much, everybody, for joining us. We appreciate your time. And a reminder, I do have that survey that's going to pop up here in a second. And Sujay, thank you very much. Great session as always.
Thank you.